Focus here. Beta, you need to write only what I tell you, okay? Not everything written on the board, okay? Don't write everything. Definition of the collision you can write, okay? Underlined. Definition is this first underlined. Definition is very simple. Collision, or sometimes people call it impact, okay? It is the interaction between the two bodies in a very short interval of time, okay? In which a large change in momentum happens. Okay, so collision or impact is the interaction between the two bodies during very small duration in which they exert a relatively large amount of force, means large change in momentum. Got it? That is called collision. Collision means interaction between two bodies. Interaction between two bodies, that is collision. And what happens because of interaction? Beta, forces are exerted. But if this duration of interaction is very small and the forces are very large, okay, interaction is always a force. Interaction between two bodies always force, okay. Both bodies apply force on each other. Forces are equal and opposite in direction, that we already know. But when these forces are relatively very large, okay, and the time of interaction is very small, such kind of interactions are called collisions. Impulse is the quantity, collision is event, okay. Momentum is changing, okay. Impulse is applied. Simple, only this one underlined, okay. Now beta, this you need not to write. I am telling you what it is written. Duration of interaction is very very small, okay. It is so small that it only permits us to know what is just before and just after. What happens during the collision we cannot know, okay. We cannot measure it. We don't need it, simply. Just before the collision and just after the collision we discuss, because the duration of collision is very small. So whatever happens during the collision is not of very much importance to us. We only talk about just before collision and just after collision. What is this duration? This duration is very very small in comparison to the whole event, okay. For example, it can be as small as 10 raised to the power minus 23 second. It's a very small time. 10 raised to the power minus 23 second for very small particles like electrons are interacting with each other, okay. And it can be millions of years for very large bodies like galaxies. There are two galaxies which are approaching each other, and after some time they will start colliding. This collision may last millions of years. But when we talk about such a large body, galaxies are very very large, then this time, millions of years, is also very small interval of time, okay. So impacts in our day-to-day life, for example bouncing of a ball, in our day-to-day life these interactions last about 10 raised to the power minus 3 seconds, okay. 10 raised to the power minus 3 seconds they last in our day-to-day life, okay. 10 raised to the power minus 3 for day-to-day life. Got it? Don't need to write that time, it is not required. Only thing that required beta is to understand that we only you have to write this, but understanding this, okay. We only talk about just before the collision, just after the collision. What happened during the collision, need not to worry about that, okay. But we can discuss, okay, just for fun. What happens during the collision? Two bodies are approaching each other with some different velocities, okay. When they collide, the velocity of one decreases and the other increases. Both apply the same amount of force on each other. momentum of one increases, other decreases, velocity of one increases, other decreases, and ultimately they reach at the same velocity. Okay, this process is called deformation. What is deformation? When the velocity of one is increasing and other is decreasing, this is called deformation. Okay, after that what will happen? They will separate out. Okay, because of the same forces. The forces which were reducing the velocities, okay, now they will separate out because of the same forces. So collide and separate. This whole process happens. So in this process what happens? First deformation happens, the shape of the object changes, and then reformation happens, means shape of the object regains. It comes to its original shape. A ball strikes the ground, shape of the ball and ground both changes. But it changes for a very small interval of time. And because of that change, a large force is applied, like a spring. Because the shape of the spring changes, elastic force acts. In the same way, when the shape of the object changes, elastic force acts. And this elastic force changes the momentum, and finally the new velocities are achieved by both of the objects. Okay, this is the process. We will understand that pictorially also. But collisions are of two types. You already know about them. One collision, our macroscopic observation, when two objects are directly coming in contact with each other. Okay, like a ball hitting the ground, two cars colliding. Okay, collision means directly touching each other. This is one type of collision. We call it direct collision. But there can be one more type of collision in which actually two things are not colliding with each other. They are coming close to each other, and because of the repulsion forces they again move away. So it is not always compulsory that things will touch each other, then only collision will happen. No. Collision can happen even without touching, because when the repulsion force is very strong, it exactly behaves like touching each other. Yes. Best example is the Rutherford's experiment of bombardment of alpha particles on the nucleus of gold. Okay. So what happened in that? Alpha particle goes, it approaches the nucleus and it deviates from the path because of the repulsion of the nucleus. It happens. So it is not actually touching the nucleus. Alpha particle is approaching the nucleus. We call that distance of the closest approach, the closest distance that it can reach. But then repulsion becomes so strong that alpha particle cannot move further, and it will deviate at some angles, and 1 out of 10,000 alpha particles can return back also. Okay, because it is going straight. So that is a head-on collision, straight collision. So it can return back. In reality, what happens? All collisions are indirect collisions only. When two things come very close, repulsive forces gives us feel of the touch. These are the repulsive forces. No two objects can touch each other. Repulsion becomes so strong that we feel like that two things are touching. Actually they are not touching. They cannot touch. Two nucleus can never touch. Two nucleus can never touch, because two nucleus have, when they come close, the force between them become infinite, because R, what is the repulsive force? Force of repulsion will be F is equal to K Q1 Q2 upon R square. When R approaches to 0, the force become infinite. Yes or no? So it is not possible that R becomes 0. When R becomes 0, the force of repulsion become infinite. No two objects can touch each other. But in day-to-day life, at macroscopic level, we can say that there can be direct contact or there can be indirect contact also. Because of that, there can be deviation. Let's say there is big planet, okay, and some asteroids passes over, okay, close to that planet. So that asteroid can change its path. This is also a collision. If the asteroid is changing the path because it is moving close to the planet, it is also example of collision. just like alpha particle is deviating when it moves close to the nucleus. So these are all collisions. So no need to write this beta. Effect of collision. What is the effect of collision? Two things changes: momentum and kinetic energy. Because when two objects are coming close to each other, they have kinetic energy. They have velocity, they have kinetic energy, they have momentum also. So when they come close to each other, momentum changes for individual particles. Okay, not for system, but for individual particles. There is a one particle and there is another particle. When they are coming close to each other, the momentum of both of these particles is changing. And kinetic energy can also change. Okay, so collision changes two things: momentum and kinetic energy. This thing you can write. Momentum changes, collision changes two things: momentum and kinetic energy of particles, of bodies. Okay, important thing is these interaction forces are very, very large, but they are internal force for the system. Yes or no? When two bodies are interacting, A and B, there are A and B, they are interacting with each other. They are interacting because of internal forces only. For this whole system, force is internal. Yes or no? The force of collision, force of reformation and deformation, it's an internal force. So it cannot change the momentum. Can it change? No. But there can be external forces. There can be external forces. Yes or no? Those external forces can change the momentum. But there is a catch here. Very important thing. Internal forces cannot change the momentum. That's clear. But external forces also cannot change momentum, because external forces are non-impulsive forces. And the time is very small. Time of observation is so small that we can ignore the change in momentum because of the external forces. Yes, velocity can change. But if the observation event is so small, for example, there is a ball, okay, that is moving and it explodes. So just before the explosion and just after the explosion, momentum is conserved. Why? Because although there is an external force, gravity, but that external force is not an impulsive force. It takes time in changing. And the explosion is a very, very small interval of time. It's a very small interval time event. So we can say directly that just before the explosion and just after the explosion, momentum is conserved. Is it clear? Because the internal forces cannot change. Internal forces are impulsive force, definitely. They are very large amount of force. But those forces are internal. Internal forces cannot change momentum. And external forces can change momentum. But here they are not changing because time of observation is very small. Okay? Time which is event happening is very small time. That's why we can say that change in momentum because of the external forces can be ignored. So we can apply the conservation of momentum for the collisions. Just before the collision and just after the collision. Not after a large time. No. Just before and just after only. Okay. So for event of collision, we are applying the conservation of momentum. For kinetic energy, we cannot say like this, that a kinetic energy will also be conserved. No. In an explosion, if sound is produced, energy is released. So some of the energy of the collision can convert into sound. Some of the explosions generate heat also. So that energy is because of collision. Some energy can lost in the heat also. So kinetic energy is not conserved in collisions or in explosions. Even in explosions or in collisions, kinetic energy is not conserved. Kinetic energy before the explosion, after the explosion can be same. Can be same. Okay? But conservation of kinetic energy, nothing like that. So conservation of momentum is always true in all interactions, even at the nucleus level. Conservation of momentum is true. But are types of collisions. This you have to write. Okay. On the basis of direction of collision. On the basis of direction of collision. How are the things colliding? If they are colliding along the line they are moving in, it means if their velocities are like this and the forces are also like this. Got it? The interactive forces and their velocities are exactly on the same line, then we will call it a head-on collision. Head-on collision means motion in the same line and colliding force is also in the same line. Okay? Velocities are in the same line and colliding forces are also in the same line. This kind of collisions are called head-on collision. Clear? Then comes oblique collisions. Oblique means interacting forces are like this, but velocities are not along this line. Okay? Oblique means not at 0 degree, that is called oblique. Other than 0 degree, that is called oblique. Oblique projectile also we have studied. Yes or no? So this kind of collision is called oblique collision. You can write these definitions. Head-on collision and oblique collision. Oblique beta direction also changes. Okay? They don't move in the same direction. Collision in which the particles move along the same straight line before and after the collision. This is called head-on collision. Before and after they move in the same line. Just like alpha particle that moves straight into the nucleus returns at the 180 degree. Okay, so that alpha particle is doing a head-on collision, and all other alpha particles which are deviating at any other angle, they are doing oblique collision. Oblique collision means when they are moving their initial velocity and the final velocity are not in the same line. Initial and final velocities are in same line means head-on collision. If not in same line means oblique collision. She is sleeping. Note it down, beta. I have brought 2 chocolates. Who deserves these chocolates? नहीं, 1 chocolate for the highest scorer, है ना? You can take. One chocolate. No, I will not give this to anyone. I will eat it. मिलेगा उसको भी. अभी मेरे को एक और चाहिए, विद्या को भी देना पड़ेगा ना उस दिन. Promises are promises. Done बेटा? अरे बेटा, write it fast. Done? Note down this. When they are not moving in the same line before and after, this is called oblique collision. Means they deviate at some angle after the collision. Okay, this is called oblique collision. Tell me one thing, there is a ball that is hitting at the 90 degree at the wall. This is ball, this is wall, this is hitting the wall. So this if this angle is 90 degree, beta, what kind of collision it is? Head on. Okay, because after the collision the ball will move in the straight line. कैसे नहीं, मतलब 90 डिग्री बोल रहा हूं ना मैं, नहीं करेगा. मैंने कहा ना कॉलिजन, कॉलिजन आप जस्ट बिफोर द कॉलिजन, जस्ट आफ्टर द कॉलिजन, बेटा ग्रेविटी विल हैव नो इफेक्ट. Just before the collision and just after the collision, gravity have no effect. Okay, and if I say this is a wall and some wall is coming like this, hitting it and moving like this, so this collision is oblique collision. Okay, actually oblique collisions are also the combination of two head-on collisions, 2 or 3, we can say like this. Okay, oblique collisions can be, their components can be made, velocities can be made in 2 components. Write it fast, beta. We want to at least complete the theory of the collision today, so that we can do questions in the next class. Little. हाँ बेटा. Now on the basis of kinetic energy, beta please focus. If kinetic energy before the collision and after the collision is same, if kinetic energy before the collision and after the collision is same, we call it elastic collision. What do we call it? Elastic collision. Okay, जरूरी थोड़ी है सेम रहे, कंपल्सरी नहीं. मोमेंटम will always be same. Kinetic energy can be same, cannot be same. Okay, there are rarest of rare chances where the kinetic energy will be same. In practical life there are no collision in which kinetic energy remains same, because in all collisions there is some sound. Kinetic energies never remain same, but there are some theoretical ideas in which we assume the kinetic energies to be same before collision, after collision. Best example is the collision of the air molecules, ideal gas, collision of the molecules of the ideal gas. We assume that these molecules are colliding elastically, their momentum changes, but there is no loss of kinetic energy. Okay, if there were any loss of kinetic energy, the gas keeps on cooling down. Yes or no? So ultimately the gas will become liquid. Because of loss of kinetic energies, temperature will go down, so their vibrations and translations will slow down. So we can say that in any ideal gas, collisions are perfectly elastic. Newton gave one theory about light. We call it corpuscular theory of light. He assumed that light is like particles. Okay, and these particles collide elastically. That's why reflection of light. Reflection of light is just like a ball reflecting from the wall. Elastic collision, nothing else. Elastic collision, with the help of elastic collision we can derive laws of reflection, we can derive laws of refraction. Okay, so there are many assumptions. Then come inelastic collision. In elastic collision, please understand, Inelastic means before and after kinetic energy is not same. Okay, that is called inelastic. Means there is some loss of energy. There is some loss of kinetic energy. Before and after is not same. If I take a ball and drop it, okay, it will bounce back, but it will not reach up to the same height level. Yes or no? It means there is some loss of energy. Then only it is not rising up to the same height level. Otherwise, conservation of mechanical energy we can say. है ना? So, loss of kinetic energy in the form of sound. So this collision is inelastic collision. There is some loss of kinetic energy here. Perfectly inelastic collision is a collision in which there is maximum loss of kinetic energy. Maximum. It doesn't mean that whole kinetic energy becomes zero. No. There is maximum loss. There is maximum. Conservation of momentum is always valid. You can never violate the law of conservation of momentum. So it is not like that complete kinetic energy will become zero. No. Complete kinetic energy will not become zero. Okay. But there will be maximum loss of kinetic energy. This kind of collision is called perfectly inelastic collision. Huh? Yes, all is gone. For one particle it is lost. So it can be zero. I am not saying that there cannot be complete loss. Yes, there can be complete loss. But momentum will always be conserved. Now, momentum has to be conserved. Okay? You cannot violate the conservation of momentum. So you cannot stop the ball perfectly. If the ball has some momentum, initial momentum is there, there must be some final momentum also. How it is possible that initial momentum is there but final momentum becomes zero? That is not possible. So there must be some final velocity. Na? Are you getting it? So we cannot say that complete velocity is lost. No, complete velocity is not lost. Complete energy, kinetic energy is not lost. Some kinetic energy remains. Okay, but there is a maximum loss. Okay. Perfectly inelastic means maximum loss of kinetic energy. Is it clear? Note down. Maximum loss of kinetic energy. Okay. Now there is a very specific feature by which we can identify inelastic collisions. Whenever the two bodies stick together after collision and they move together, this kind of motion is called inelastic collision. Why do they stick together? The reason is simple. Their both velocities become same. Okay, that's why they stick together and move. So this kind of motion is called inelastic motion. So if I take a mud and throw it on a car and it sticks with the car, okay, so it's a perfectly inelastic collision. There is nothing like perfect elastic collision. Okay, elastic collision means perfect elastic. Clear? Elastic collision means perfect elastic. Hold on this. अभी नहीं हुआ, अभी होगा, अभी तो है दो तीन चीजें और. अगर थ्योरी ठीक से समझ में आया देन यू विल बी एबल टू सॉल्व द क्वेश्चंस. बेटा देयर आर समटाइम पीपल call one more type of collision. They call it super elastic collision. Super elastic collision, kinetic energy increases. Okay. Explosion is example of this. Bomb explosion is the example of super elastic collision. Initial velocity, initial kinetic energy was less, but after explosion kinetic energy increases, है ना? So super elastic collisions are there, but this is not the part of our course, so we need not to worry about this. Okay. Write it first. Done beta? Beta, this is the process of collision. Try to understand this. This is the event of collision. Okay, event of starting the collision, in which two objects UA and UV, obviously UV will be greater than UA, UA will be greater than UV, then only there will be collision, otherwise there will not be any collision, है ना? So UA is colliding with UV or A is colliding with B. So when they collide like this, their shape starts changing, okay, and their speeds start changing. This is called deformation period. Deformation period means deformation, shape is deforming, okay. Both of them achieve the same velocity. Both of them achieve the same velocity. So momentum changes here, okay. We can call it that deformation change in momentum. Deformation change in momentum, okay. Deformation is this D force is acting, okay. For deformation D force is acting on both of the objects. D is the deformation force. So that is the change in momentum for deformation. Got it? Now comes restitution. Restitution means gaining its shape again. The force is again acting in the same direction. Now the speed starts increasing. U finally same velocity, but now it starts changing again. This finally become VA and this finally become VV, and both of them have gained the same shape, original shape, and now they will separate away from each other. They have gained the original shape. This is called restitution period, means reformation period. So deformation and reformation. Got it? Here also the momentum is changing because some force is acting in the deformation process. Reformation process we call it reforming force, and the change in momentum will be R dt. Okay. So this is called deformation impulse. This is called reformation impulse. Okay. Now deformation impulse and reformation impulse can be equal or cannot be equal. They can be equal also. If they are equal, then initial kinetic energy and final kinetic energy will be same. It means elastic collision. Okay. If they are not equal, let's say reformation impulse is less than the deformation, then what will happen? There will be some loss of kinetic energy. It means inelastic collision. Okay. So from here we comes with the definition of elastic and inelastic collisions. So for elastic collisions, both of these are equal. Both of these impulses, both of these change in momentums are equal. Got it? You will understand it. Just note down this. You understand the process, what is happening? They are coming close, shape is changing, again regaining the shape. In both the processes, momentum is changing. In between, both of them gain the same velocity. Okay? Yes, beta? The momentum is conserved. We are talking about the momentum of one object, not both. Okay? Individual momentum decides kinetic energy. Yes, p square upon 2m. At instant of maximum deformation, velocities are same. We did this concept in spring also. Do you remember? I said in the spring that at the instant of maximum deformation, maximum compression, speed of both the objects is same. Do you remember that? Both of the blocks is same. The same concept. Exactly similar thing happens. This is also elastic force. Spring is also elastic force. Okay? So spring block system is one of the example of collision only. During for one movement it happens. This is the complete duration of change process. Okay? So if I say beta conservation of momentum, if I want to say, I can clearly say that ma into ua plus mb into ub is equal to ma into va plus mb into vb. Yes or no? That's how I can write conservation of momentum. Okay? Done beta? Beta, we are defining one word, one quantity we are defining, that is called coefficient of restitution. Okay? Coefficient of restitution simply means, beta please focus here. Coefficient of restitution simply means impulse of recovery upon impulse of deformation. Okay? Means impulse of reformation upon impulse of deformation. After solving this, because mass will be cancelled on both sides. Okay? So change in momentum will be actually change in velocity. Yes or no? Because mass is same, so it will be cancelled. Numerator, denominator masses are same, so they will be cancelled. So change in moment, this E can be directly written velocity of separation along the line of impact. Separation means after collision, how are they moving away? That is called velocity of separation. Velocity of separation can be written Vv minus Va. Try to understand. These are two. Okay? This is UA moving with UA and this is UV. If I ask you what is the velocity of approach? UA minus UV? Yes or no? That is the velocity of approach, UA minus UV. Let's say this is 10 meter per second. This is 5 meter per second. What is the velocity of approach? 5. They are approaching each other with the 5 meter per second. Correct. So UA minus UV will be the velocity of approach. And if I say velocity of separation, after collision they are moving away. This is VA and this is VB. They are moving away. If they are moving away, obviously this VB will be greater and VA will be smaller. Yes or no? Then only they are separating away, na? What if VA is greater, beta? Then they will collide again. That is not possible. It doesn't happen. If the VA is greater than VB, what will happen? Then collision is not stopped yet. Yes or no? Definitely VB will be greater than VA, then only there will be a separation, otherwise they will move together. Are you getting it? Okay. So from here you can directly say velocity of separation is VB minus VA. It can be opposite also, but values can be put with sign. Okay. So this formula very important. Definition of E. E is equal to VB minus VA upon UA minus UB modulus. Modulus means value of E is always positive. Okay. Whatever be the sign we get, we will always consider value of the E as positive. Okay. E lies between 0 to 1. E lies between 0 to 1. Okay. E lies between 0 to 1. 0 means perfectly in elastic collision. Okay. 0 means perfectly in elastic collision. In elastic collision. 1 means perfectly elastic collision. Got it? And anything between is inelastic collision. There is nothing like perfectly elastic collision. So we will only call it elastic collision. Okay? We can call it only elastic collision. And this is called inelastic collision. In between it is inelastic collision. Okay? What is the spelling? Double S or S only collision? Simple as, na? Only one S. Double S? Double L is there. Double L is there, but S is only one, na? Not working. So for today, we have completed nearly all the theory. A little part is left. But in the next class, we will start the questions on collision. Okay? किसको दूं मैं ये टॉप? अक्षरा, यू कैन टेक दिस. ओके. विद्या को पहले मिल चुकी है एक बार.